Hello everybody, welcome to session 2 of chapter pressure. The objective of today's class is to define density and upthrust, to list conditions required by a body to float in liquid, to verify law of flotation, to explain Archimedes principle, and to solve numerical problems based on Archimedes principle. Before we go in detail about different laws in this chapter, first of all, let us discuss about these two important terms that we use in this chapter: density and upthrust. The term density, in simple language, density is related to heaviness or lightness of object. If any object is heavy, then we can say that density is high. Similarly, if any object is lighter, then we can say that object has low density. For example, if we compare between stone and cotton, then you can see that cotton is lighter and stone is heavy. So in this case, what we can say is cotton has low density and stone has high density. So this is the way to understand density in common way. But if you want to define density, then density is the mass per unit volume is known as density. Mass per unit volume. So the formula can be density equal to mass per means by volume. So density equal to mass by volume, and its SI unit is kilogram per cubic meter, because from the density formula we can get the unit of density. Mass SI unit is kg and volume SI unit is cubic meter. So that's why SI unit of density is kilogram per cubic meter, and CGS unit is mass CGS unit is gram and volume CGS unit is cubic centimeter. That is why CGS unit of density is gram per cubic centimeter. Similarly, of thrust. Here, up means upward and thrust means force. So whenever any object is put on the liquid, then we can feel that liquid is always pushing that object upward. So that very upward force is called upthrust. But it's not exact definition, because whenever you keep any object in liquid, then the object weight takes it down. And just opposite to that, the upthrust wants to take the body off. So these two opposite force act here. So to float that object, the upthrust must be higher than weight. So here, whatever the upward force that you get, that is somehow deducted by the weight. That is why we don't say exactly the upward force is called upthrust, but the resultant upward force is called upthrust or buoyant force. And since it is force, so its SI unit is also Newton, and its formula is F equal to dgv. Here F means upthrust, d means density of liquid, g means acceleration due to gravity, and v means volume of immersed body. Immersed means into the liquid. The condition to float. So to float in any liquid, that body must have less density than liquid. So if density of body is lesser than density of liquid, then that body always float on the surface of liquid. Example, paper floating in water. So you can see paper has less density than in water. That's why the paper can float in that water. Similarly, if the density of both body and liquid are equal, then in that case also body will float, but not on the surface, but under the surface of liquid. Example, iceberg in water. So iceberg and water, they have approx equal density. So you can see that iceberg floats under the surface of water. But if density of body is more than density of liquid, that body will sink in that liquid. Example, stone sinks in water. Here stone has more density than in water. Now few questions let us discuss. Egg sinks in normal water but floats in salty water. Why? So here you can see the picture. In normal water egg is sinking, but in salty water it is floating. Why? The reason is that the normal water has less density, and according to relation, if the density is less, then upthrust is also less. That means this egg is experiencing less upthrust. Because of that, this egg is sinking. But when you add salt in it, then density of this salty water will increase. And when density increase, upthrust also increase. That means this egg will experience now more upthrust. And because of more upthrust, this egg will sink in that, float in that water. Similarly, there is another question. A beaker containing water is taken to pole and then equator. Where does water or beaker exerts more upthrust and why? So beaker with water, once it is taken to pole and then to equator. So question is asking here, where does the water exerts more upthrust? So here the G and F, we need to understand the relation. So the pole of Earth has more G because radius is less. So the place where the G is more, upthrust is more. That means at pole the water will exert more pressure because G more means upthrust also more. So that's the answer is water exerts more upthrust at pole than at equator because value of G is more at pole than at equator. Similarly, which body, either half immersed or fully immersed body, experiences more upthrust? The answer is very simple. It is related to the this relation. So fully immersed and half immersed. So this V means volume of immersed body. So if the body is immersed completely, then that body will have more V. More V means more upthrust. That's the answer is fully immersed body experience more upthrust. Law of flotation. So generally what you understand is if the density of body is more than density of liquid, body sinks in liquid. This is the general understanding. Like example in this picture you can see, so this rock, key, screw and block, they are sinking in water. The reason is they have more density. So according to general concept, if the density of body is more than density of liquid, it sinks. So you can see here they are sinking. Whereas you can see plastic ball, log of wood, or maybe toys, they are floating in water. The reason is their density is less than liquid, that is why they are floating. So these are general understanding about floating or sinking. But when you take the example of ship, the ship is made of tons of steel and the steel has more density than the water. Though the steel has more density than water, but here ship is floating. So what could be the reason? Here you can see the screw made of steel is sinking. What is the reason? Because its density is more than water. But here it is also made of same steel, but this steel having high density, it is floating. What is the reason behind it? The reason is that if the body can displace liquid equal to its weight, then that body can float in that liquid no matter either the body has high density than liquid or low density than the liquid. The condition is it has to displace liquid equal to its weight. If anybody can displace the liquid equal to its weight, that body can float. So same condition is with ship. The ship is designed in such a way that it can displace the liquid equal to its weight, and because of that it can float in the liquid. So condition is weight of body must be equal to weight of displaced liquid if that body has to float in that liquid, or you can also say mass of body must be equal to mass of displaced liquid. One equation here you can see, a needle made up of iron sinks in water but sheet made up of iron floats in water. Why? Then here you are not going to answer based on density. Here what you have to say is, as needle cannot displace the water equal to its weight, it sinks. But the ship made up of iron floats in water because the ship can displace the liquid equal to its weight. Similarly, there is another question. If a person is of 60 kg, how much water he has to displace in order to float in that water? As we discussed, to float in the water, the weight of the body must be equal to weight of displaced liquid. So since the weight of that person is 60 kg, if he has to float, then he has to displace the water equal to his weight. That means he has to displace 60 kg of water to float in that water. Archimedes principle. So this principle is linked with immersed body. So to make you understand easily, here spring balance is measuring the weight of the body in air. If you don't see here anything means air is in surrounding. So the weight of this body in air is 20 Newton. So when you immerse this body into the liquid, then because of upthrust, it will measure less weight. So that's why it is written 14 Newton. So before keeping this stone here, this special vessel is called Eureka can, where liquid was filled up to the neck of this nozzle. And this beaker, this special vessel is called Eureka can. So this is the beaker kept in order to collect displaced liquid before it was empty. And when you keep this, when you immerse this stone here, then since it was up to the neck, the moment you keep here, then because of the volume of this stone, some of water will be displaced, and that displaced water will be collected here. So what is the surprising thing you will see here is, it was 20 Newton in air, and when immersed in liquid, weight is found 14 Newton. So here loss in weight is 6 Newton. Surprisingly, what happens is, if you measure the weight of this displaced liquid by this body, it comes 6 Newton. So means when a body is immersed into the liquid, then what happens? There will be loss in weight. And whatever the loss in weight takes place here, that is equivalent to the weight of displaced liquid. So it will come exactly 6 Newton. Similarly, if you compare the first figure and the last figure, so here weight in air is 20 Newton, and here you are immersing the body completely. So when you immerse completely, then it will experience more upthrust, so there will be more loss in weight. So it was 20, now 10 means the loss in weight has become 10 Newton. So if you measure the weight of displaced liquid, it will also come exactly 10 Newton. That means loss in weight of body is equal to weight of displaced liquid. So this is the statement of Archimedes principle. When a body is immersed in liquid completely, here completely or partially, what happens? Loss in weight of body. You can see there is a loss in weight of body, and that is due to upthrust. That's why in bracket it is mentioned upthrust is equal to weight of displaced liquid. This principle we can apply in both liquid and gas. So according to this statement, what you can write is upthrust. Here upthrust is equal to weight of displaced liquid. And upthrust, in place of upthrust, we can also write loss in weight of body. So upthrust means loss in weight of body equal to weight of displaced liquid is same. And here, how can you find loss in weight of body? The weight in air minus weight in liquid. So that's why in place of loss in weight of body, we have written weight in air minus weight in liquid equal to same weight of displaced liquid. So the formula we got here is weight in air means W1, weight in liquid means W2, and weight of displaced liquid is W3. And submarine, hot air balloon, hydrometer, ship, etc., they follow this principle. Now here we have numerical problems based on Archimedes principle. So you can see here weight of body in air is 20 Newton and has displaced 5 Newton of water when it is immersed in water. Calculate its weight in water. Now this 20 Newton is weight in air. So weight in air we always symbolize by W1 equal to 20 Newton. And a 5 Newton is weight of displaced water, and weight of displaced water we always symbolize by W3 equal to 5 Newton. Now what is asked? Weight in water. So means weight in water we always symbolize by W2 equal to what? So according to formula, W1 minus W2 equal to W3, and W1 means weight in air is given 20 minus W2 is asked to us equal to W3 is given 5. So if we do the calculation, then W2 equal to, it comes 15 Newton. That means the weight of body in water is 20 Newton. So this is one model of numerical. Now let's go to another numerical. When a body is immersed in liquid, its weight is found 12 Newton, means weight in liquid is 12 Newton, means W2. And has displaced 3 Newton of liquid, means the 3 Newton is weight of displaced liquid. The question is asking what is the weight in air, means W1 is asking, and upthrust means F also is asking. So weight in liquid, as question said, 12 Newton. Weight in liquid, weight in water is same thing, W2. Weight of displaced liquid, W3. Weight of displaced water, W3. The symbol is always same. And weight in air, W1. Weight in air, W1 is asked to us, and upthrust F equal to what? So same formula we are applying here. W1 minus W2 equal to W3. W1 is asked to us, W2 is 12, and W3 is 3. So if we do the calculation, then with W1 equal to 50 Newton you get. And upthrust formula is, if we go to previous slide, then upthrust equal to weight of displaced liquid, means F equal to weight of displaced means W3. Even W3 equal to W1 minus W2 means upthrust equal to, you can write W1 minus W2 also. So here, to make easy, I wrote upthrust equal to weight of displaced liquid. Even in place of W3 you can write W1 minus W2, because W3 is equal to W1 minus W2, answer will come same. So weight of weight of displaced water is 3 Newton, so we wrote 3 Newton. In place of W3, if you write W1 minus W2 also, answer will come same, because W1 is 15 and W2 is 12, so answer will come 3 Newton. So in this way, we can find weight of body in air is 15 Newton and upthrust of liquid to body is 3 Newton. So in this way, we complete this session 2 of chapter question. So see you in next session. Thank you.